Hello, welcome to my channel led by Sensei Kushal. In this session, we'll understand basic concept of Kafka and why we need Kafka. Before starting, I request you to subscribe to my channel led by Sensei Kushal. So let's start the session. Okay. So for example, suppose you have this e-commerce store and we have multiple microservices in place. So we have order microservice, payment microservice, address microservice, user microservice, cart microservice, notification microservice, and so on and so forth. So these microservices will interact with each other. So if you place an order, then the user microservice will be called and updated like order has been placed. Then the user microservice will fetch the address from address microservice. Likewise, we have the setup here for e-commerce web store. Okay. So consider you have placed an order in the same e-commerce store. So for example, this microservice, the inventory microservice will call the billing microservice and then billing microservice call the order and the notification. So this inventory microservice will update the DB like the order has been placed and reduce the article which has been placed. So suppose you have 10 articles, then this microservice will update the DB like order has been placed for one item. So reduce it from the inventory. Likewise, the billing microservice will generate the invoice for the user because the order has been placed. Then this order microservice will update the order status like order has been placed. And then the order microservice will send the request to the notification microservice, which in turn send the SMS to the customer like order has been placed. So in this simple example, it does not a unidirectional, right? The billing microservice will also call the notification microservice to send the notification to the user saying the bill has been generated. Then order microservice will also call the notification microservice, right? And this order microservice will also call the inventory microservice to tell the inventory microservice to update the DB, right? Because the order has been placed. So with this scenario, suppose you have a complete ecosystem, and this ecosystem comes under tightly coupled architecture for microservice implementation. So order microservice will interact with payment microservice as well. One payment microservice will interact with cart microservice. Order will interact with inventory microservice. Order will interact with notification to send the notification to the user. The cart microservice will also call the user microservice because once the order has been placed, user cart should be at zero, right? And the payment microservice will also interact with the notification microservice to send the notification to the user like order has been placed. So these microservice, when you have a millions of user, then these architecture of tightly coupled microservice is a mess, right? You cannot handle the load when this type of tightly coupled architecture was used in the implementation of microservice when the user load is very high. Okay, so what is Kafka and why we need Kafka? So in place of order microservice interacting with payment microservice directly, we have placed Kafka broker in between them. So order microservice will no longer interact with payment microservices directly. It will interact through the Kafka broker only. Likewise, the payment microservice will not interact with order microservice. It will only interact through the Kafka broker. So let's understand with the example. Suppose you have placed an order from a food delivery app. Okay. So seller will not come to the buyer to send the package, right? So, sir, this is your order. Please take it. Or buyer will not come to the seller to take the parcel, right? The seller will send the order to the warehouse or the delivery partner, or the delivery partner will reach to the seller on getting order from the buyer, then delivery partner deliver it to the warehouse. There can be possibility for e-commerce stores like there can be a multiple location. So suppose the seller is in Delhi, it will send the item to the Delhi warehouse, and then Delhi warehouse will send the order or the item to the Mumbai warehouse, and from the Mumbai warehouse, that order has been delivered to the buyer, right? So in this approach, the buyer will not interact with the seller, or seller will not interact with the buyer. They'll just interact through this delivery partner. Right? So there is a concept in Kafka called the event. So order microservice will send a lot of events to the Kafka, and these Kafka events are nothing but has the Kafka key value here, timestamp, and metadata. So whatever the orders or what numbers of order has been placed, all the events will be generated and sent to the Kafka. And from these Kafka, the multiple microservice will take these events as per their need or as per their configuration and process it. So the payment microservice will receive the event and process the payments. Inventory microservice will take this event from the order microservice and updates the DB. And the notification microservice will take the event and update the notification about the order has been placed. Okay. There has been the case where these inventory microservice, order microservice, and payment microservice were generating n numbers of events, right? Because there can be loads of user using the application at the same time, right? So multiple events will be generated. Suppose this is for order, this is for inventory, right? And this is for payment. So multiple events will be generated. So these microservices, which are generating these events into the Kafka, okay. So these are called the producer microservice, okay, or the producers, which will produce the event to the Kafka. And these microservice, like the user microservice or the inventory microservice, which will consume the events, and the notification microservice. So notification microservice will consume the event from order, or inventory microservice will take the order event as well, and then user microservice will take event like payment or order microservice, right? So in this way, these microservice will take these events into consideration, and due to this, these microservice will call the consumers, because these microservice are consuming the events from the Kafka, which has been generated by the producer microservice. Okay, these microservices will not interact with these producers directly. They will interact through this Kafka broker only. Okay. So, let's consider a situation where like multiple microservices are generating. So these are like producer microservice, and they are generating n numbers of event, right? And what will happen for the consumer microservice? How they will identify like which event is from which microservice? So there is the concept in Kafka called the topics. So inventory microservice will always generate the event into the inventory topic. Order microservice will generate into the order topic, and payment microservice will generate the event into the payment topic. Okay. So consider this situation where these microservices, or there can be multiple microservices, are generating events in their particular topic, right? So let's understand the use case which can be beneficial if we implement the Kafka. So the first is chain of event. So consider an example where this inventory microservice is generating an event into the topic. Okay. And this event is consumed by another microservice, which is called the alert microservice. On this alert microservice, what happens is when you place the order, and suppose we have kept a threshold of 2. So when the item in the warehouse becomes less than 2, then this alert will be generated. And this alert microservice will consume this event from the inventory microservice and generate an event for restock microservice. Okay. Then this restock microservice will take the event from alert microservice and restock the inventory. So to maintain the inventory in the warehouse. So these chain of event can easily be managed using Kafka. There is one more use case like real-time updates. So consider a situation when you placed an order in a food delivery app. Okay. And on the time of placing order, it shows 20 minutes to deliver, right? And the distance from the place, for example, is 10 kilometers. Okay. So it will take 20 minutes. So when you check or track the order, 2 minutes or 5 minutes, you see that 18 minutes are remaining to your order to reach your doorstep, and the kilometer has been reduced to 5, right? So in this way, this real-time updates, okay, this real-time update. So order remains like 5 minutes away from you, and the distance become 1 kilometer. This real-time update of a delivery partner of your food delivery is updated using the real-time feature of the Kafka. So these events are generated in the real time in the form of streams, and these has been updated to your system, okay, on the real time. So this is the good use case for Kafka implementation. Okay, consider the same example for the real time update. So example, this order microservice is generating orders from Delhi, Mumbai, Goa, Pune, Punjab, anywhere the order can be generated for the e-commerce website, right? So there can be millions of events generated, and how this can be handled. So the Kafka has partition concept where the each topic, so microservice like order microservice will generate into the order topics, but these order topics will also be partitioned based on their location. So the order placed to be delivered in the Delhi will be kept in this partition. Okay, call it as a P0, and orders placed for Mumbai will be kept in the P1 partition, and order from this microservice or from any other microservice, if the order is from Goa or is for Goa, then it will be uh, stored inside this P2 partition of the order topic. So how this is decided? It is decided by the developers who are implementing this concept, where we decide where this microservice will produce the record in which partition. Okay. And taking into consideration, suppose these uh, has been generated, these events has been generated in different partitions. And for example, suppose this inventory microservice is consuming from these partitions. So millions of orders has been placed from different location at the same time. Your company is going through a sale or an annual sale or Black Friday sale, something like that, and this microservice is getting loads of events from different partition or different topics. So how this will be managed? It will not be managed, and you will experience a slowness, or you will kept on seeing the loading icon, right? So to resolve this type of situation where multiple partitions or multiple events has been generated which needs to be consumed by the same microservice, we use multiple instance of the same microservice which will be reading from different partitions. So for Delhi, suppose these two instance are defined. For Mumbai, these two instances are defined, and for Goa, these instance of microservice is defined. So if, for example, this microservice is not working or is down for some reason, then this microservice will be allocated to the Mumbai orders as well. So this will update the database for Mumbai orders as well. So this concept is called consumer group. All these microservice instance will be under the same consumer group, which will be reading from the order topics. So in this way, we are handling with the fault tolerance as well. If this one instance of microservice is not available, we assign another instance of that microservice to handle the load of the partition of the same topic. So this handling of the microservice which has been not working and transferring it to the next microservice instance, this has been done by the Kafka broker. Okay. So this is the Kafka broker. Kafka broker is the actual um, worker which is storing your data into business, and it is maintaining the Kafka topic and partition for the processing. So, for example, suppose Kafka broker 3 is not working or is down. you will never lose the data. The partition to the topic A is there in the broker 2. So this broker will take the responsibility to generate or to handle the data which has been there in the Kafka broker 3. So to handle these broker concept, like which brokers are active or not, Kafka use this tool called the Zookeeper. So what Zookeeper do is it maintains a registry for all the active brokers in the cluster. Okay. So if any one broker is down, it will assign or another broker will start handling the events from the broker or from the topic. So it's a task of Zookeeper. Zookeeper also partition the Kafka and take a responsibility for the leader broker. Also, Zookeeper facilitates the election of the leader. So there has been a one leader and others are followers. It also handles the metadata and configuration for the Kafka brokers. So after Kafka version 3.0, okay, Kafka introduced KRAF, also known as Kafka RAF. In this Kafka RAF, there is no need of Zookeeper as of now, okay, from now onwards. And this Zookeeper or all the implementation of these Zookeeper will be handled by the Kafka broker only. So remember, after this version, Zookeeper will no longer required. Thereafter, Kafka RAF will be into the implementation. Okay. So thank you for watching this video. I hope this helps you. And if you like the video, please subscribe to this channel. It takes a lot of efforts to create such kind of videos. So show your love by subscribing to the channel. And if you have any queries, you can ask in the comment box. Thank you.